Hello students, welcome back. How are you? I hope you're all fine, healthy, wealthy and strong. Okay students, you are doing your studies, I hope. Okay, so we are going to do some more questions based on the area of parallelogram and the triangles. Okay, so in that case we are having this particular question and this is a little bit different question, so I think we have to include this question in our exercises. So here xy is a line parallel to side BC. So here I have drawn the diagram for you guys. Here it is xy is line which is parallel to BC. Okay, and we are having triangle ABC. So the triangle ABC is this triangle ABC. Okay, now we have given that if BE is parallel to AC, BE is parallel to AC, right? So we are having this BE parallel to AC, right? Okay, so BE, here E point is here, so this BE is parallel to AC, right? Okay, so we are having these two sides parallel to each other. This is given to us, right? And should I use different color, students, right? So okay, this EB is parallel to this AC. Here again we are having the CF parallel to AB. CF parallel to AB. Now this is the point F. So you are having CF parallel to AB. Okay. Okay. Now you're going to meet xy and E and F respectively. Show that this, you have to show that ABE is area of AB is equals to ACF. So ABE and ACF. ABE and ACF. These two areas are equal. We have to prove that thing. We have to prove this thing, right? Okay, this is our question. Okay, so how we are going to prove that? We are going to use the same concept of the parallels, parallelogram, triangle and the related areas of them. Okay, so first we need to identify which area we are talking about. ABE. Now A is this, B is this and E is this. So this complete area is equals to this ACF. ACF. Okay. So we are going to use the parallelogram and the triangle theorem, that the area of a parallelogram is equals to half the double the area of a triangle, and we are going to also use this criteria that the if two parallelograms are having the same base and between the same parallels, then the area of them is going to be equal to each other. Okay. Now students, look at test x, y and this AC. We are having EB is parallel to AC. That means EB is also parallel to NC. Part of parallel lines are also parallel to each other. Okay, so these two lines are parallel to each other. Also given that BC is parallel to EF. If BC is parallel to EF, we can say that BC is also parallel to EN. Again, the part of parallel lines are parallel to each other. That means EN is parallel to BC and EB is parallel to NC. That means this EN-BC is a parallelogram. Similarly, we are going to prove that MFCB is also a parallelogram. So these two parallelograms we are having, and these two parallelograms are on the same base. That means area of these two parallelograms are going to be same. Then somehow we are going to prove that this is a parallelogram and having the base EB here, and it is also having this triangle AEB. So AEB, this triangle and this parallelogram are on the same base, EB and AC. Okay, and having the same parallel. Similarly, we can prove for that also. So here, from here we are going to prove it. Alright, okay. So talk about the proof section. Here we will be saying that xy is parallel to BC, implies that EN is parallel to BC. How? Part of parallel lines. Okay, parts of parallel lines. This is the first thing. So this BC is parallel to EN. Also, it is given to us that EB is parallel to AC. EB parallel to AC. This implies that if EB is parallel to AC, that means EB is also parallel to NC. EB is parallel to NC. Again, the same thing here. Part of parallel lines are equal to each other. If this is so, EN is parallel to BC and EB is parallel to NC. That means this is a parallelogram. Okay, this implies that EBCN is a parallelogram. I'll say that similarly, if we talk about this EB, not this EB but this AB. Okay, so AB is parallel to FC. It is given. This will again say that this MB is parallel to this FC. Okay, and here also again XY is parallel to XY is parallel to BC is given. This will again implies that if XY and BC are parallel to each other, that will again imply that MF and BC are parallel. MF and BC are parallel to each other. By these two things, we can say that, what it is saying, that MB and FC are parallel to each other, then BC and MF are parallel to each other. That means this is going to be a parallelogram. This implies that this is the first thing we were having. Okay, and this is the second thing. Here we are having MBCF is a parallelogram. Second. Okay, these two parallelograms, the first parallelogram here, the second parallelogram here, are having the same base BC and between the same parallels. Okay, so first and second parallelograms are between the same parallels which is XY and BC and same base is BC, implies that area ENCB is equals to area MFBC. Okay, this is something is of worth having in our question. We are going to use it in further calculations. Okay, the further proof. So I am going to have it and rubbing the other things of it. Now, after this, that these two parallelograms are having the same base and between the same parallels, okay, we had proved that. Now we are talking about these two triangles that we had to take. The triangles were, this is the first triangle and this is the second triangle. Now look at them. If I am saying this is a parallelogram, this is a parallelogram here, right? And we had proved that it is a parallelogram too, right? So if I am talking about this parallelogram XB and C, this parallelogram EB and C, okay, is having the base EB, and this triangle EAB is also having the same base. So I am having these two parallels, okay, and between these two parallels I am having this parallelogram, and I am having this triangle and this parallelogram on the same base EB, and between the same parallels AC and EB, okay. Now triangle ABE, okay, ABE and parallelogram EABC, ENBC, okay, ENCB, or okay, so ENCB, these two are having common base, which is a common base EB, and same parallels. What are the same parallels? EB and AC. This implies that area triangle ABE is equals to half of area ENCB, or we can say that half of area, because ENCB area is equals to MFBC, and this is the third equation of ours. Understood? Okay. Similarly, if I talk about these two parallels, AB and the second parallel is FC. So if these two are the parallels, and I am having here the parallelogram MFCB and this triangle AFC, this is having the same base FC, okay, and between the same parallels AB and FC, okay. Similarly, triangle ACF and parallelogram MFBC having same base. The same base is FC and same parallels. The same parallels are, the first is FC and the second is AB. This implies that area of ACF is equals to half of area of MFBC. Okay, and this is the fourth one. By comparing the third and fourth, you can easily say that area ABE here will be equals to area ACF here. And this is what you had to prove. Okay. Now, note this. Noted? Okay. So let's move to the another question, the next question of ours. Okay, so next question is here, that in figure we are having in figure ABCD is a pentagon. So ABCD is here a pentagon, ABCD. This is a pentagon. A line through B parallel to AC. So the line through B, right, parallel to AC. Line through B parallel to AC. So through B and parallel to AC is this line. Okay, meets DC produced at F. So this DC is producing and it's meeting it here at F, so that this AC is parallel to this BF. Okay, now we have to show that ACB equals to area ACF. Okay, so let's work on that proof. We are talking about the first one. In figure, AC is parallel to BF. Okay, if AC is parallel to BF, we have to prove that ACB area is equal to ACF. Okay, and this is very simple to prove because we are having these two triangles between the same parallels and the same base. Okay, so AC is parallel to BF and AC is common base, implies that area of ACB will be equals to area of ACF, this area ACF. Why? Because you are having between the same parallels having the common base. So this is the first part which have been proved. Okay, then about the second part. The second part is we have to prove that AEDF. Okay, let's talk about that. Right, so again we are having these two parallels. Okay, after having these two parallels, we were having these two diagrams, these two areas equal to each other, right? Okay, now proof, the second number. We have to prove that AEDF. What is AEDF? AEDF. This complete area should be equals to ABCDE. ABCDE. Okay, this complete area ABCDE. ABCDE, this area. Okay, how we are going to do this? We are having this common area in both these two, and these two areas are equal to each other. So we are going to use the previous one data to prove this part. Okay, by first proof, we are having area ACB is equals to area ACF. Now what we are having, this area is common in these two areas. Okay, so adding the common area is what? AECD to both sides. What we'll be having? Area ACB plus area AECD will be equals to area ACF plus area AECD. Right? Now, you'll be having these two areas. Look how these areas are going to work. ACB. So this area ACB plus area AECD. This area AECD. this complete area, is this area is going to be the area AEDF, AED and F. No, this is not the area. So is this the area ABCDE? So this area is ABCDE. Yes, this is the area ABCDE. So can I write here area ABCDE? This area is ABCD will be equals to area. These two areas, what these two areas will make? Here we are having area ACF. Okay, so AC and F is this area. This is the ACF area. And again we are having this common area AECD, which is this area. Now this complete area, is this area is AEDF? So AEDF, yes, this area is AEDF. Okay, area AEDF. So we had proved that, hence proved. Okay, so there may be some diagrams that that you will be finding difficult to solve, but when you will be applying the given conditions, then these areas will be very easy to solve. With that note, student, I am concluding this lecture. In today's lecture, we had done two questions based on some important concept of area between the parallelograms, area between the parallels, and same base of particularly triangles and parallelograms we are talking about. We had used both the things here, area of parallelogram also, area of triangles also, relation between the area of parallelogram and triangle also, and the concept of between the same base and the same parallels. Okay, so with this note, I'm going to end this lecture. In next lecture, we are going to do some more questions, and after that, I guess so, we will be completing the session of this chapter. Take a very good care of yourself, students. Bye bye.